Good, thanks. So, welcome to the kickoff meeting of the control plane management, or I would say control plane lifecycle management. So, uh, first of all, I would say across all the work streams, if you look at this work stream, this is basically a much broader topic as compared to the other topics, and this topic requires, I guess, first of all, a narrowing at some point what is in scope, what is out scope, and what do we exactly want to do with the control plane components as such, right? So in the agenda, I have first added point to how to first of all define this work stream. So I would say, as part of this work stream, I guess, though this is very long term, we should probably try to take care of how do we create, how do we upgrade, how do we scale if we want to, how do we want, and how do we really delete the control planes as such for the cluster API managed clusters, right? And there are a couple of major aspects that has to be discussed in this work stream. So uh, first of all, if you are following the use case talks and the requirements talks that had been recently created, right? So with respect to control plane, there are much higher level objectives now. So if you look at cluster API project right now, we have one standard way of managing control plane where we go ahead and we create the master machines. And we say that these are the dedicated machines which hold your control plane and they are the brain of your cluster. And now there are also conversations happening at this. I have overheard a lot of times in Kubernetes community that we need to think of the ways where we do not really denote the master role or the node role and so on. All the nodes should be considered same probably. And with that also there are other approaches. So one approach is also there where you could also have a control plane cluster, where control plane cluster is the one, or let's call it the management cluster, where the management cluster can hold the control plane of the workload clusters as well. So this model is also famously known as kubeception model. There have been talks in KubeCon and so on. So this model is also very famous. And with this work stream, probably it's a good idea for us to evaluate the different ways of managing the control planes and decide which one makes sense, and whether we should be able to support all different ways of managing the control planes and so on.
So I know one of the things that we were considering when we were talking about this within VMware is there are use cases where both of the two different approaches really make sense. So when we were initially trying to break down how we could see this happening, we envisioned basically managing, being able to abstract away the control plane enough so that it could facilitate both approaches.
Yes, I think I would also completely agree on this. I guess both of the approaches have their own trade-offs, and I guess both of them makes a lot of sense. So, but then something comes to us is that how do we move ahead? So I guess for the second approach, which is the management cluster approach, which has been discussed a lot of time in the community calls, but I guess we could never actually produce a document which actually states how would it look like eventually, right? So that's one action item or something that I wanted to decide through this call, that probably if we agree that there is really importance of that approach, then probably I'll try to create one proposal doc on this approach, that how would the model look like, or how would the migration from the existing way of doing clusters to the other management way of doing clusters would look like. That's one thing that we have to do. But then with the existing approach where we have a dedicated master machines, I think still there are few open questions. We still require a good document which states that what are the nuances of this approach, right? For example, if there is only a single master machine, or if there are multiple master machines, and if there are multiple master machines, then how do you want to manage the control plane across multiple master machines? So, for example, how do you scale up your HCDs if you want to scale your number of master machines and so on? So I think one document is also required which can more or less state all of the internal requirements of this approach. And this approach, for this particular approach of the master machines, it would be nice if we have some volunteer who would have been doing something in this area and is willing to write or help me giving more internal aspects to it, because I have not gone through it or in detail in this approach. So I'll keep it into the doc. Would be nice if anyone who is interested in contributing can probably do it. You can do it on all the docs, but I would need a primary contributor there somehow.
You can assign that to me, Hardik.
Ah, sure. Great. Thank you, Jason. Cool. Then, yeah, then I also copied the diagram that we had in the use case document. So for the folks who are not probably aware of what are these two different main approaches, then probably last two blocks of this diagram is what is showing the difference. And if you have still questions or something, I guess this is a good platform to actually talk about it and talk the internal details of it, because then otherwise, in the talk it will just falls through the cracks. So okay, then this was the one aspect which I wanted to discuss, and we shall proceed with this with respect to this aspect. We'll probably proceed with the docs with both of the approaches, and if there is one more approach, if someone knows any other way of doing things, then we can probably, it's a good time to edit here and probably work on that doc as well.
So the one other approach that we're probably going to want to consider is the managed control plane approach. So if somebody wants to manage, say, a GKE or an AKS or an EKS cluster, we would want to be able to model that type of control plane as well.
Does it mean that cluster API controller should be able to bootstrap a GKE cluster, EKS clusters, and so on? Or
yes.
Yes, that is also, I guess, an interesting use case. So all the managed Kubernetes offerings could also be spawned via the same controller. So a user goes to the cluster API and should be able to tell that I want a cluster which is conformant to the cluster API. That's one way. The other way, it should be conformant to the GKE. But with respect to GKE, then or any other provider. And okay, yeah, I guess we should probably add that here. Cool. No, thanks. Anything else anyone has in mind which might be different from the existing approaches that we have discussed, or slightly different confusions, or does it interfall, or any use cases which might be different from this? Probably, David, I think you at Samsung, you guys have been looking into the management cluster concepts, right? So if you have any inputs, or if you have any other, if you think there could be any other better way of doing, then we could also include that. At least at this phase, we could have different documents and decide that which makes more sense and which all should be considered in one group.
So I'm not sure if this belongs here or not, but I'll just put the question out there. Should the control plane solution be responsible for providing access to the Kubernetes API by either exposing an endpoint and then probably also credentials?
I almost think it has to.
Yeah.
I think it was also one of the requirements for the project that we set.
Right. I'm just highlighting it here in case we want, because I feel like those are some of the hardest problems, but they're also sort of prerequisite to starting, right?
Yes. Okay.
So I think one of the challenges that we're going to have as we get deeper into the design too is that we do overlap with at least two of the other work streams. One of those being the data model work stream and the other one being the extensions mechanism work stream. So to avoid trying to rabbit hole into those topics here, what we should probably do is bubble up the requirements that we have as far as like the data model. So instead of talking about exactly what the data model looks like, we can talk about kind of what are the requirements that we have of the data model? What attributes do we need to be able to get from the user? What attributes do we need to be able to publish back to the user, things like that. And then for the extension mechanism, we should probably just black box that for now and just call out that, you know, this needs to happen through an extension mechanism and not get too deep into the design around what that extension looks like.
Yes, I think that makes perfect sense. We would require, even while thinking through the control plane management, I was easily able to see there are a lot of overlapping with the at least different other work streams, mainly the data model. Okay, makes sense. Okay, then moving ahead. So also I see something in the use case document that it was discussed that what's a good way of doing the control plane engineering. So I think the way we say the day one of deploying the control plane and giving the Kubernetes cluster is good. I think that's the easy task. The hard task is to maintain the cluster. So when user starts using it and you see a real load coming in, then the control plane that we have already deployed may start suffering. So then the question comes that how do we want to make sure this control plane always stays healthy? And if you can in general refer it as the control plane engineering. And there then the points could come where whether we want to scale up a couple of components. When I say scale up, it's not a generic term. I think each component has its own very different characteristic and has the scaling part has to be taken care of differently. For example, etcd, the horizontal scaling doesn't make sense. I mean, unless we have a very smart way of horizontal auto scaling, it cannot be as very bare horizontal auto scaling. But probably if you have a single node etcd instances, then probably the vertical scaling could make more sense there. In a similar way, if you look at the API server, then for API server, both horizontal and vertical scaling makes sense, but then we have to decide which one takes the precedence, and we need to come up with some better or good algorithm that when to do what. So this is also a much broader topic. And in this round, I wanted to see that how do we see that whether this should fall under these work stream or whether probably there should be a completely separate efforts to take care of these. Or
so I do think that we do need to have scaling in scope, because if we do talk about being able to support multi-node control planes or multi-pod control planes, you are inherently tackling at least scaling up of the cluster. And if you want to be able to delete that cluster, you're also talking about being able to scale down that cluster as well. I think we need to have that in scope. I don't necessarily know about auto scaling right now. I think maybe solving the general case of scaling up and scaling down would probably be a higher priority. The other concern that I see is we've talked about 3 different kind of mechanisms for actuating the control plane, and this could potentially be quite different based on the implementation backing it as well. So like in the case of like the managed service control plane, you may not even be able to scale that. That may be some that you can only specify at instantiation time, if at all.
yes, I think that's a very good point. So in terms of control plane engineering, I think we have a list control in the managed services. You can literally not do anything in case of any of the, as long as the experience I have with GK, you don't get to see control plane. I guess AWS also, in EKS also, I guess you don't get to see the control plane components as such, right? And I'm not very sure, but that's correct. So if that's the case, then probably we will have to define the goals very clearly that this applies to only this set of clusters. And if you're going with the managed services, then you don't get this kind of functionalities. But in general, if you think more towards our mainstream use case where we want to create a fully fledged Kubernetes clusters on our own from the scratch, and in that case, I guess if you plan to support a lot many clusters, then I guess the scaling of the control plane makes a lot of sense, right? So here as well, I would say if you consider it as in scope, then it makes sense to probably come up with a design doc where how do we overall look at it and which component requires what kind of scaling there.
I think it's important to consider like what aspects we consider in scope and out of scope. So if we take the simplest case of the API server, it can be very easily horizontally scaled because it's stateless. And I think if we consider a managed service that will kind of maintain the high availability for us potentially, then the API could be as simple as number of replicas or automatic, and it's a string. Does that, like, I think we should really try to get as simple as possible.
Yes, so it is true, I guess, but there are also some complications. So this also comes from the real experience with the API server. So as we know, what API server really does is basically try to mirror the full cache, right? And what becomes very normal is that if you have a very large cluster, then there is some base memory that is always going to be used in all of the instances of the API server. So for example, if you so which basically means that 2 pods with 1 GB each RAM probably is not equivalent of 1 pod with 2 GB RAM, because in the first case you will end up basically replicating a lot of cache. So the point is taken that I think there should be a simpler mechanism to do it, but I guess there will also this specific aspect will, I think, also require the hints or the inputs from the folks who have some real experience with in running the control plane. So but I would say let's take it in scope for now. Let's try to define a document that what are the low-hanging fruits. So if there are really easy ways to just horizontally scale API servers for now, we can probably enable it as a first step. And whenever we see the real complications, we try to scale in terms of vertical as well.
Is this something that we want to take into and associate with the previous docs that we talked about, and try to define it specifically how it would relate to the different types of implementations?
Yes. So I think in the previous docs there should be a separate section which explicitly outlines that whether how would the auto scaling part, how would the scaling of the control plane part would be considered in each different approaches. I think that makes sense, and this could also be a differentiator, mainly that way how better you can manage the control planes in different approaches. I think this makes sense. So we'll try to keep it in a way that in the previous docs of different kinds of implementation, we'll try to put an explicit section which talks about the scaling of the control planes and how it will be affected. Yeah, thanks. Okay, any other comments, anything? Cool then. So then I also was trying to understand how does the Kubernetes version upgrades affect the control plane. So when we talk about the life cycle of the control plane, it definitely includes the phase where you want to upgrade from one version to another version, and then there are also minor versions, there are major versions, and with all different kinds of implementations, this can be tackled in completely different ways, right? So here also, I guess we have a good chance to decide that how do we want to tackle the upgradation of the control plane components, or is it something that we take in a more generic way where in general in the cluster API we decide, because this also includes the worker machines as such, because it might not ever make sense that we only upgrade the control plane components and not the worker machines. Then it's more or less a spillover on different regions, that probably in the node life cycle also this will be considered, right? So should we take it now as in scope or out scope is something that we have to consider.
So I see it as being in scope. And I think there are two components here to this. I think one is, how do we surface up how you define an upgrade, and that could be part of kind of something that's common despite the implementations. And then there's the other component that's going to be very implementation specific, because how you would manage a control plane upgrade for, say, a machine-based deployment versus a pod-based deployment would look considerably different.
Yes, agreed. And there also, at least for example, we would explicitly for the machine based, if there are major upgrades and we probably want to get a new machine, new master machines one by one. And if there are minor versions, we probably just swap the necessary images for the new pods to come up and so on. So then here also we would require a separate doc. And I could see, because I said in the start, this seems a much broader topic as such. And I think we might not want to dive into all of the aspects immediately, but as and when we get the capacity, we'll probably start to produce more documents, right? And
So it seems,
also after the
yeah, it seems like we as the control plane work stream have an easier task than the nodes, because with the Kubernetes upgrade flow, you upgrade the master services before you upgrade the nodes. So if we want to focus on upgrading the master components, I'm thinking about the complication of needing to coordinate the nodes and drain the nodes. I don't think that's in scope for this, obviously.
No, but that's something that's in scope for the node lifecycle management work group for sure.
Right, right.
Yes, that's true. And so I think we can then also discuss this part explicitly in the general meeting and check whether we want to take care of this now or whether we can just park it for now unless there are good solutions at the worker machine level and in the node lifecycle work stream, and then we start looking into it. Because I think the heavy work of the cluster upgradation is required in terms of the machines. In terms of the control planes, probably all we want to do is to, at the end, all we want to do is to quickly upgrade if there are pod based, just upgrade the images, otherwise just upgrade the machines, which are the master machines. Cool, then we keep it for a discussion for the central cluster API meeting.
Okay.
Fine. If anyone have any questions, any doubts, any suggestions, please feel free to dive in. Guys, this meetings has been ending always for other work streams also pretty quick. And whole reason of this work stream based meetings was that we can discuss these small things, the nuances of the approaches, which we were not able to discuss in the central cluster API meetings like that. So this is a good platform. Even if you want to think loud, this is a good platform, I would say.
So I do want to say that one of the things that we should keep in mind is that not everybody that's interested in this topic is able to attend the synchronous meetings. So wherever possible, I think we should try to collaborate, through asynchronous means. And the meetings are great for working through some things, but we need to make sure to stay inclusive as well, I think.
Yeah, completely agree with that. Many APAC regions, it's pretty late for them to join. Okay, so moving ahead. So one more, I would say, a miscellaneous topic is the extensibility part of the control plane. So looking at the existing cluster, I would say the cluster API controller, a controller which is dedicated to manage the cluster objects more or less. And we know that if not now, probably in the near future, we will start seeing a pattern where there are a lot of responsibilities, small things which needs to be integrated in this one controller. And at least we have seen it with experience in Gartner that the small things becomes small pieces, which creates a lot of complications, and eventually you have one big controller which is looking over probably 100 different clusters or 200 different clusters, and then you start seeing the problems where the 105th cluster has to wait for some time before other clusters reconciliation is over, and so on. So that's where the question or the a new way kicks in, where whether we want to think in terms of the extensibility. So whether there should be one big mammoth controller which does everything, or whether there should be a way where we should be able to provide the extensions which are dedicated to smaller responsibilities. For example, for a quick example, so infrastructure controller. So a controller which is dedicatedly not all kind of infrastructure on the cloud provider, but the infrastructure resources which are essential for the cluster API project. So this controller's job should be probably to only make sure that given a specific infrastructure resource or dedicated CRD which contains a specific resource, this controller's job is to make sure that this resource is available, healthy, and it's there on the cloud. So the central controller then doesn't need to really worry, or it doesn't really need to have any kind of code paths which has to look there and do anything about it. Then there could be other examples like the DNS management. So there could be, and DNS is also sometimes DNS gets tricky. So it does so happen that the initial requirements of the DNS later on changes. It just says I want some other alias now, I want something else, and you probably want to change certain DNS entries, or you probably want to make sure that now I want more entries to be supported for the existing load balancer and so on. So now there could be an extension mechanism for the DNS and so on. So I wanted to also know your views. How do you look at this concept, and whether we should think out in this direction, if not now, but in future?
So I think we should avoid thinking about concurrency as a problem with having one binary versus many binaries, or like one controller versus many controllers. Because right now, the core cluster controller blocks in certain cases where it doesn't need to block, because now we have status. We're using status in a more appropriate way. So I think, like, just for the sake of reducing complexity, we could have kind of the core controller that via the extension mechanism, whatever that turns out to be, delegates certain tasks to infrastructure specific binary, or even a Go library, whatever it turns out to be, but that we use states to implement a highly concurrent controller, right? So those are like two separate concerns. We could have it block everywhere and have many controllers, or we can get better about doing things concurrently. That's my thing.
Yeah, and I think this is a tricky topic anyway, because it's partially going into some of the concerns of the data model, like whether you're dealing with one object or multiple objects, and it's also dealing with the extensibility mechanism as well. That said, if we do want to support more than one type of implementation, I think that pretty much mandates that we would have to leverage some type of extension mechanism to do so.
Yes, I would also agree. This heavily overlaps with the data model. I could not attend the kickoff, not the second meeting of the data model today, but in the minutes I could see that there are already some instances of the infrastructure management and so on. So I don't have a clear path ahead, but I would say let's keep it here for now, and whenever we see a real need of it, we move in this direction and keep it out of scope, at least for now, this topic for this work stream, right? I think that sounds reasonable as of now to me.
One thing I want to point out, though, is that this workstream, I think one of the core functions of control plane lifecycle is signing the certs, like generating a CA, signing all the certificates. And if this is a problem I'm currently facing in my implementation, if the core controller blocks while it's calling out to OpenSSL or whatever it's doing, that's an issue. Like, I think we should set up more states like certs, pre-cert creation, and then have that be asynchronous, and then post-cert creation. Yeah, obviously these are some minute details, but I think we want to try to be as non-blocking as possible for performance.
So I get the point, but I did not understand that. How does it? So you mean to say that we should have some? So what is the exact proposal here? So for the certificate management, we should have a different code path which can.
Well, so like let's say there's some control loop for the controller, right? And if we put the if we allow certificates to be minted on a Go routine, for example, and the core control loop is capable of delegating to a different Go routine context based on where it actually blocks, then you can just increase your concurrency for the sake of performance. So it's basically like we're going to have some function that either mints the certificates or delegates that to something else. And this is an implementation detail, but we should be careful not to block when we don't need to block, when a lot of I/O is happening. Yeah.
Yes, I think this applies in general. I would say that this is purely very much into the implementation. Yeah, that I think makes sense, and I also agree that we should keep this in mind for all the aspects. Fine, then I would edit this part for now. Then one last topic which I could think of. So when we talk about the control plane, we basically are serious about something, and we need to make sure that whether we kind of project already available which can efficiently do the backup and restore. I am not looked into it, but probably it's that way. And then there will also be question that how to exactly make sure that if you lose the control plane, then how do you really can reproduce the entire control plane again? And if there are more such extensions, not specifically the extensions, but some controllers which are not the core Kubernetes, but which would probably fall under, from the cluster API point of view, they would probably fall in the control plane region, because, for example, this component has to run along with the control plane component itself. It has to run side by side with the etcd, right? So how do we tackle such different controllers? Whether we try to include them in this work stream, or whether we consider them as add-on. If there are some other add-on work stream, then we take it there. Or any suggestions, any comments?
Can you give me an example of one of the controllers that you're referring to as maybe being an add-on or maybe being in and out of scope?
So I didn't get it completely. What did you say? Sorry?
I didn't understand which components you thought might be add-ons. I wanted to know if you had an example of an add-on that we might want to assume as part of the control plane lifecycle project or work stream.
So, for example, one is the etcd ADM, then probably something else probably could be, let's say, the vertical pod autoscaler. If you decide to do the vertical scaling of any, if you decide to do vertical scaling of any of the control plane components, then any custom written controllers, at least for us, we have deployed something called AWS LB advertisers, where there is a dedicated controller which makes sure that the LB configurations for a given cluster is always up to date and healthy. And if user goes ahead and messes with the infrastructure, then this controller basically makes sure that something is really wrong there and overwrites or does something. So there could be, I guess, there could come requirements which will be on top of the core Kubernetes controllers. Then whether we take care of them or we consider them as something different and tackle it separately.
So to me, I prefer to try to keep some of that out of scope for now. We may want to keep in mind during the design to not preclude the use of those things, but I don't necessarily know if we should, that should be in the scope as we start to define out what control plane management looks like.
And so it basically means that I think I also believe that we should only be focusing on the core Kubernetes control plane components and not really worry as of now for other probable control plane components, which would more or less the add-ons. And probably there should be a dedicated work stream as well for this specific issue, because even for the control plane components, I think there would be few things, few add-ons, controlled way of, I would say, deploying certain components. Those kind of facilities would be required very soon, and we would require some better knowledge there. So I'm not sure. There had been discussions on around the cluster bundle project, right? But I don't know what is the status there and what's the plan ahead. But let's see if we can have a new work stream for the add-ons sooner as possible.
So I feel like the vertical scaling and then like independent etcd management, independent of the entirety of like API server, etcd, etc. Those may be use cases that should inform our design, but may not be necessary to implement.
Yeah.
The value with etcd ADM is if it has a well-defined configuration, I think that could be used by other methods to bootstrap etcd.
So the big concern that I have right now is we're still trying to tackle just basic control plane management at this point. And as far as implementation so far, I don't know if anybody's implemented at least machine-based control planes outside of kubeadm today. So we would potentially have complication around, okay, do we force users to deploy more machines to support etcd completely hosted separately, or do we still try to do co-located etcd management? Then how do we merge kind of etcd ADM management with kubeadm management on the same host? I think there's a lot of potential complication that we have around all of those different things that might be better solved through another iteration rather than trying to tackle for V1 Alpha 2.
I think one thing that's interesting is I can imagine two different primary audiences. One is sort of higher level tooling, which may want fine-grained control over like how etcd is configured, where the API servers are, etc. But then I think about the normal user, and honestly, I don't think they care. I don't even think that I necessarily want to tell them the difference between 1 master, 3, and 5, right? Like they probably want to know, like, does it support a single failure or 2 failures? And maybe that's even too much, I don't know. But they want capabilities, not specifics. Maybe that'll become more clear if we document our use cases.
So I think one of our responsibilities is to define like where the extension points are. So with the idea of etcd being a machine versus a pod, right? That we define that as an extension point. So I think for V1 Alpha 2 to be really useful to a lot of people, that maybe there's a default implementation that spins up etcd on a machine using an etcd ADM config, or that same etcd ADM config could be an input to a delegate. You see what I'm saying? Does that make sense?
I mean, I agree that we need to identify the extension points. I don't think I understood the particular comment.
Oh, like I think Jason was trying to get at, like, maybe we don't try to define something that's different than spinning up etcd on machines, but I think we should really leave that open based on a default implementation versus a extension mechanism.
Right. I would agree with that. I think there's still some question, and this is maybe outside of the scope of this, but when you think of extension mechanisms, I wonder to what extent should we flesh out the extension points? Should we say that, like, here's your extension point for etcd, and here's your extension point for the API servers? Because then we have this multitude of different concepts that when the default implementation of kubeadm is used, there's like no difference. I mean, assuming you use like kubeadm with stack masters, that fine-grained breakout of the extension points may not be necessary. So as a similar thing from the data model discussion, there's this proposal of having an infrastructure controller. I wonder, in a similar way to what I just said, I wonder if that's yet useful, because for a particular infrastructure provider, they may or may not decide to have like N different infrastructure controllers, right? Like how you map, how they want to break up their infrastructure into small, well-defined controllers, maybe outside of the scope of us defining the extension mechanism.
Yeah, so I think it's an opportunity for some kind of manifest for an extension provider where, let's say this is based on gRPC and there's some external, like you don't even have to call it a controller, you can just call it like an RPC server or something, and you define which functions should be delegated to your RPC server. So like you want the default kubeADM, you just let that happen, but you want something different to happen for etcd-ADM, then you're provided some data that allows you to do that.
So this gets it, like one of the ways that I've sketched this out with some folks in the past is you could define all of these different kind of multitudes of extensions, and then you can have basically, you know, just like a mapping that could, you know, map all of those. So you can have basically like individual provider implementations for everything, but then you would have one config that would say, this is kind of like the roadmap for how I want to be able to stamp out clusters with this provider config, with this type of bootstrapping config, and wire it up that way. So it would basically be like a template to be able to stamp out clusters, and it would dictate kind of which of all of the extension points are used.
Yeah, I think it could be part of the CRD even, like, but that seems to get a little complex. I think maybe when you install a provider, it tells you which extension points it will implement, something like that. Yeah.
So to me, it seems there are basically there would be two different categories. So components which are essential for cluster API to run, there could be extensions there as well. So for example, the infrastructure extension that we are talking about, it could be infrastructure controller or gRPC server or whatnot. That's one way which is essential for cluster API managed cluster to run properly. But then there are other extensions which are more or less add-ons. So for example, the etcd-ADM, which is something which is going to back up and probably restore some kind of features of your given etcd cluster, manage the etcd cluster on top. So that kind of features are considered as add-ons. So if I don't have that, I will still be able to run my cluster. It will still be there. Just that it's up to the user to decide that what kind of clusters with what kind of reliability I want to create a cluster, right? So that's true that it definitely falls under overall in the cluster API, that how do we manage this. But as of this round, with this particular work stream, I would say we might want to probably think in future that for the core controllers extension, the core cluster API controllers extension, for example, the infrastructure, we might want to think. But for rest of the extensions which are just an add-on on top, and which might be just adding new values to the given cluster, we might probably put them out of the scope for now, and we see how to tackle them in future. And we have more mature mechanisms with add-on specifications like cluster bundle and whatnot.
Yeah, I absolutely agree. So things like adding, let's think of an add-on that's definitely out of scope. The dashboard, which is deprecated, right? Like, what I'm getting at here is not that you have an extension mechanism at the very end, which is like deploy whatever manifests you want. I'm talking about like at the point where etcd needs to come up, you either have a default implementation that based on being able to provision machines is able to provision etcd machines, or provides enough information to the provider that it provisions etcd in some different way.
So I almost think that it might actually be like just a different, it could potentially be just a completely different implementation of the control plane as well. You know, because we've talked about machine-backed instance control plane. We've talked about management, the pod base for the management cluster, and we've talked about external managed service, the etcd-ADM, and control plane being separate kind of managed resources could potentially be just another type of control plane implementation. Because I'm assuming that whatever extension mechanism we have would allow us to find specific configs that are related to the kind of control plane that we're standing up, things like that. So that may be another option there as well.
Yes, and I think at some point I also worry a little bit that if we support a lot of orthogonal ways of maintaining or managing the clusters, then for each of different implementations, I guess there would be a lot of heterogeneous behaviors. So just as we talked, the control plane engineering would look completely different for both of the approaches, right? And I'm sure that there would be other many aspects which would look very different if you go in one way and not the other way. So I think it might also make sense that if you have a very clear document which says these are the trade-offs exactly, and then we decide that our focus would probably, or the default implementation would always probably be looking like this. And if user decides to go the other way, then these are the facilities which are available there. But probably everything might not be available because it completely depends on the flexibility that you get with different implementations, right?
So I think part of it comes down to how are users utilizing the cluster too, because the pod-based control plane does not overly make a lot of sense for the user who just wants to use Cluster API to deploy a single self-managed cluster. But it does make sense in some of the use cases where the user wants to manage multiple clusters using kind of a management cluster. So I don't think we can necessarily choose one default method that will work across all of the use cases that we're trying to support. So I think, you know, at some point we are going to have alternative implementations, and that's just going to have to be okay, I think.
Yes,
Yeah.
agreed.
I think like our task here is to define kind of the minimal requirements. Like take etcd for example. Like you need an endpoint, and it needs to be a functioning etcd cluster, and the API server probably needs a client certificate. So if we define those requirements, then if the provider does something very strange, like use a shared etcd cluster, that we still have some guarantees based on our requirements that it works in the end.
Yes. Yes. So agreed more or less. So I guess we need approaches, just that the common denominator should be there, but then it seems if we have multiple implementations, then there could be a pattern where X thing is available in one implementation but might not be available in the other implementation. And that should be fine as long as we know that the common denominator is the dominating one. It is enough on both of the implementation. Then is always a possibility of small things here and there. That should be perfectly fine, I would say. Okay. So that was more or less what I could think of with respect to this work stream. And if anyone else interested in this round who have any ideas, any suggestions, what else could be considered here? Anything I missed probably?
So right now we have an owner for the pod-based management cluster architecture, and that's you, Marty. I've taken up ownership of the dedicated, or the machine-based. Do we have anybody that wants to own the kind of managed service control plane aspect?
So which is which? Who owns the pod-based one?
Hardik has that one right now.
And then managed service, meaning control planes run on machines, but there are many clusters?
No, like backed by a managed control, managed service offering control plane, so backed by GKE.
Okay.
AKS, something like that. Yep.
I'm most interested in the pod based, so yeah.
Oh, that's great. Then we can collaborate.
I'll take the managed service one as well then.
Yeah, sure. Then, if you want, Jason, we can also collaborate on the third one, which is a managed service. I would also like to know details there. We can think it through. Let's see. So, okay, good. So we decide that we go ahead with at least these three proposals initially. The topics which are after these three proposals are about autoscaling and version upgrades. I would say let's be focused on, first of all, decide the control plane approach first. Let's work on these three proposals first, come up with some better answers there, and then we decide what to do about the autoscaling and upgrades and so on. If that sounds good enough. Fine. Good. Anything else anyone has in mind? We still have 6 minutes left.
Sorry. Yeah. So I am actually kind of confused about the diagram now. So, who's taking on self-managed? Or do we have the notion of self-managed anymore?
So self-managed isn't really pictured here. It's basically the first diagram, and then there would be a pivot to pivot the components.
Got it.
There really isn't much of a difference with respect to the control plane management in that use case compared to a management cluster that, you know, is machine-based, really.
Well, yeah. Well, the big difference is the node refs, right? And that's still an open concern for me, because if you run, yeah.
Yeah, no, I get that. Yeah, that's one of the things that the node lifecycle management group is going to be tasked with, is making sure that we have the ability to do remote node references and not just local node references.
Makes sense.
Yeah.
Hey, sorry, I joined late. For some reason I didn't get. I see the invite in my email, but I didn't get an invite on the calendar, and so I missed the majority of the meeting. It looks like maybe you talked about the control plane or etcd specifically. Did I miss? Was there a long discussion on that?
So not specifically. So we were taking etcd ADM or etcd as an example. So we were mainly looking at. So we were looking at the perspective that what should be in scope for this work stream. For example, if there are add-ons like etcd ADM, which could be plugged into the control plane, whether we consider managing them or instrumenting them inside the control plane as part of this work stream or not now. So that was the main discussions around, and we felt overall that these features are good to handle or tackle, not at least exactly not now with this work stream, or there could be a separate work stream probably in future where we explicitly consider such components, which could be etcd or some autoscaler or other components which can be an add-on for the given control plane and doesn't necessarily need to be the core control plane.
Okay. I kind of have a question around that. So I know that, for example, kubeadm today will bring up an etcd cluster, and it does that, I think, with the right control plane join. And the way that kubeadm does this is by passing around data that is needed each time that you add a new etcd member. It passes it around through the Kubernetes cluster. I think that it's deployed. So it deploys the first control plane, then it posts some configuration on there, and when you run control plane join, that'll fetch the necessary configuration required to add this new etcd member. Is that do I have that right? Maybe somebody can either correct me if I'm wrong or.
There's two bits of configuration that are added. There's one where it's like just the common kind of control plane config, which will include like the endpoints and all of that stuff, the general kubeadm config. Then there's a second piece that's a basically time-bombed encrypted set of certificates that are needed for bootstrapping the control plane as well. And that one specifically, the encryption key for that is stored nowhere on the cluster and needs to be input at both bootstrapping time for the first control plane instance and then subsequent ones. But yeah.
Okay. But I wasn't thinking so much about, you know, like the security aspect, but more of, you know, if I'm adding a second etcd member to an existing cluster, or a third, or, you know, at any point that I'm adding an etcd member, I need to provide that member about all of the current members in the cluster. That information comes from somewhere. I'm assuming that it's being, you know, it's being pulled down by kubeadm when you run that control plane join. So my question is, and this, you know, this is working, and it works great. But my question is, for something like etcdm needs that same data. It doesn't really need anything necessarily more than what kubeadm needs, right? If that's sufficient to bring up a new etcd member, then that's sufficient for etcd-adm as well. But etcd-adm is, you know, is designed to work without assuming that, you know, that it's going to be talking to some Kubernetes API. So I guess my request is that can we consider whatever information that kubeadm right now passes around to bring up these additional etcd members, can we consider adding that to the control plane types that we work on, so that you know, tooling like etcd-adm, although it's not, you know, we're not going to be working on it necessarily now or making it a default implementation of etcd or anything like that, that at least there's going to be a way to pass this, like a standard way to pass this kind of necessary data around, so that if I want to, you know, work on some, you know, etcd controller that, or some version of the control plane controller that does etcd, that it, you know, through etcd-adm, that it could, I wouldn't have to have my own provider spec for that data. I would be able to, you know, plug that experimental controller into whatever provider, for example, or it would use the common types. Sorry if I'm not making myself clear.
Daniel, I had to interrupt, but I guess we are over time. Is it fine if we can take it offline? Probably if there are small.
Yeah, I'm sorry, I didn't realize that. Yeah, I'm sorry. Yeah.
Okay, I am sorry I had to interrupt, but yeah, if there are follow-up meetings set up, then they would have been waiting.
Yeah, I'm sorry. Yeah, I totally joined late. Thanks.
No issues. We can probably discuss in the next round as well. Probably whenever in the next week we will have a new meeting. Okay, cool. So thank you everyone joining, and have a nice weekend ahead. Yeah, bye.
Thanks everybody.
Thanks.